Saxon Algebra 2, Lesson 71. Greetings, my students, to one of my favorite lessons of the entire year. I love it so much. All right, quadratic equations or quadratic expressions have been kicking around for a while now in our math lessons. They are expressions that follow this general pattern. We have an x squared term, a plain x term, and a plain number. Sometimes we have numbers in front of them. Sometimes this is an invisible one. That might be an invisible one as well. Sometimes we just get this much. Sometimes we set it equal to 0. We're going to be talking today with it set equal to 0. So this is what we call, technically, a quadratic equation. Now, this we call standard form. So let me just tell you that. And that means we've substituted in A's and B's and C's instead of actual numbers. Okay, so it's kind of like a generic form. And we know that there are 3 ways to solve. So far, we've talked about 2 of them. The first way to solve is by inspection. The Algebra 1 kids are just getting into that. That's where you look for 2 numbers that multiply to this and add to this. This works only when the roots or answers, right? The answers are relatively straightforward, simple numbers, integers, or some simple fractions. So this works only some of the time. What works every time is completing the square. You're groaning. I hear you. It's fine. I understand. Completing the square will work for any possible quadratic equation that the world can throw at us, all right? It works for everything. It's not like inspection that only works for certain kinds of problems. Completing the square works for everything. The problem with completing the square is that it is long and tedious. There are so many steps. And you know what? The mathematicians back in the day, they got sick of it too. We're talking all the way back to the Egyptians and the Babylonians and the Hindu dudes and the Arabic dudes, and the European dudes too. They all thought that this was a pain and wanted a simpler way to solve quadratics that was reliable for every kind but didn't involve completing the square. So what they did was they created a formula. And we call that now the quadratic formula. Oh, look, it's the topic. For reasons that I will tell you on another day, I call this formula the man-eating dragon. There's a perfectly good reason for that, and it'll all make sense when I tell you. I don't want to get into all that today and sidetrack you with my marvelous story. So I'll hang on to that and tell you on another day. That's what we're learning today. The great thing about this formula is it works for all quadratics, just like completing the square. It's kind of a bear to memorize, but once you memorize it, it's relatively straightforward to go from here directly to the answer. We don't have to do all the completing the square steps. So what is the man-eating dragon / quadratic formula? That. You will memorize this. We will use it a bunch this year and next year and anytime you're working with quadratics in the future of your life. What I'm going to do is show you in this lesson how we get from here to here. how are those two even related? What do they have to do with each other? How did we even come up with this? How do we know that this formula will work when we're trying to solve one of these? Now, I'm sure that a good many of you are like, I'll take your word for it. I don't really care, right? I get it. But I'm going to show you how cool it is that we can make this turn into that. Ready? So that's what we're going to do. And we're going to do that. That's technically not an example, but then we'll have two examples where we use the quadratic formula to solve some problems. All right, so follow along with me. Keep copying. We're going to take this standard form and we're going to complete the square. The first thing that we would do for completing the square is we have to get this x squared by itself, right? So we would have to divide everything by a. Oh my gosh. That's annoying. This cancels, and now we have x squared plus, and I'm gonna make this fraction a little bit separate. Normally I don't like a floaty variable, but this time it's gonna be okay. Plus c over a equals 0. Kick him to the curb. Minus c over a. And now magic number. For the magic number, we take this number, which is in the b spot, right? And we divide it by 2, or if it's a fraction, we can say multiply it by 1/2. That's the same difference. And then we're going to square it, and we draw an arrow here. Remember, this arrow helps us know what goes into our perfect square when we get to that. It's very important to draw that arrow. You'll save yourself a lot of time. Okay, so this is going to be, the magic number is going to be this. It's going to be b squared over 2 squared times a squared, which is 4a squared. Okay, so here, let me do this. b over 2a squared. Now you can see more directly how I got that. All right, that means I can take this and collapse it down, right? Like one of those collapsible camping cups. I'm going to write it as a perfect square. It's going to be x plus b over 2a. Where did I get this b over 2a? Right here. It's what's inside the parentheses when I'm completing my magic square calculation. This will be x times b plus b over 2a. Let's double check. It should multiply to this, b squared over 4a squared, yes. And it should add to this. b plus 2a plus b plus 2a would be 2b over 2a. The 2's cancel. BA. Beautiful. Okay, now we can also write this as x plus b over 2a squared, right? Because that's what this is. We're just collapsing it further. Equals minus c over a. Okay, now I'm going to take the square root of both sides, right? These cancel each other, so I'll just have x plus b over 2a, and then over here, I will have I'm just plus or minus the square root of minus c over a. Yes. Oh, I know what I did wrong. I know what I did wrong. I forgot to add. I put the magic number in here. I forgot to add it here. B squared over 4a squared. Okay, so now when I take the square root of this, I want to b squared over 4a squared, right? I'm just copying this all the way down. B squared over 4a squared. Now, before I subtract this, I want to clean up what's in here. I want to make these match, okay? So it's plus or minus the square root of the least common denominator here is going to be 4a squared. So I have to multiply this by 4a over 4a, right? That will give me a matching denominator. I'm going to move this term to the front so that that minus sign is in the middle. So it'll be b squared minus 4a times c, and everything now is over 4a squared, and that's in the pig house. Okay? So what I did here, I forgot to add my magic number. That's what was confusing me. I add the magic number, I take the square root of the whole mess, then I make these fractions match and I combine them. I bring the b squared to the front so that the minus sign is in the middle. And this is what I get on the right side. Over here, I still have the x plus b over 2a. Now, here comes the fun part. I'm going to subtract this. X equals minus b over 2a plus or minus. Now I notice that the denominator is a perfect square, so I don't have to keep that in the pig house anymore. B squared minus 4ac over, square root of that is 2a. These match, so I can write it. Wish I wouldn't have run out of space. But now I'm just going to push, I'm going to push these two fractions together. The denominators already match. So I'm just going to combine the numerator into one big thing. Ready? X equals minus b and that is the quadratic formula. We just proved it. There are other ways to prove it. That is my favorite. We were able to complete the square using letters instead of numbers, and that's how this is derived, okay? A couple important things I want you to notice about this. This is a minus sign. It is very important that you use buckets when you're filling in for this equation. There's a minus sign here, there's a minus sign here, there's a plus or minus here. There's a lot going on in this formula, and buckets will save the day for you. All right. As we simplify, we're going to simplify this area first. I'll get to that as we go. Another thing, notice that the whole entire expression in the numerator is all over the denominator of 2a. Sometimes students will copy it like this and they'll just put this part over 2a. No, it's the whole thing, all right? This plus or minus means that we're actually going to have two values for x. That's the way quadratics roll. Let's take this now and use it in a couple examples to actually solve this. 71.1. Use the quadratic formula, the man-eating dragon, to find the roots of the equation, blah, blah, blah. Roots of the equation, roots equals answers. Equals solutions. That's another word that means the same thing. Okay? So don't let that word roots psych you out. It's nothing special. All right, ready? So John gives us a really cool quadratic here. He gives us 3x squared minus 2x plus 5 equals 0. Now, John was nice to us and he put everything in a very disciplined and lovely order there. Sometimes he doesn't. Sometimes he jacks around that order and causes us drama, and we have to clean it up before we start. So that's the number one step. Ensure proper order. And by that, I just mean get it in this standard form, okay? This one looks good. 2. And you're going, why do we have steps if this is the fast way? I know. We're going to make a list, always over here on the left, of the values for A, B, and C. A is the number in front of the x squared, B is the number in front of the x, C is the plain number. The sign goes with the number, all right? So A is 3, B is -2, C is 5. This is another reason why we want to use buckets, is not only do we have minus signs in our equation, our formula, but we often have negative values. Ooh, it gets crazy if you don't do it. Okay, 3, we plug in. We plug these values into this formula. So we plug it into the man-eater. And that's this, so we get x equals minus, and what I do is I write it with my buckets first. I don't have enough room here. Minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Use the buckets, okay? Write down make sure the formula is on every page of your homework so you can see it. Then when you do the problem, first write it down with empty buckets where every A, B, and C is in this, right? The buckets stand for the empty A, B, and C places. And then fill in with your values for A, B, and C. There are 2 schools of thought on the easiest way to do that. Some people like to start here and work across, filling in as they go. So it would be B, B, A, C, A. Other people would rather run down the list. Where are the A's? Here, excuse me, here and here. Where are the B's? Here and here. Where's the C? Just there. Okay? So one way or the other, have a systematic approach to this. I don't care which, I'll mix it up and I'll do both. So you decide which way you like it and go accordingly. This time I'm going to go across. Okay, so I know that B goes here, -2, -2. Then I put A in this spot, C in this spot, and then another A down here. Right? I'm just following this pattern and filling in the proper values from my list. Now we're ready to simplify, and that's the final step. So yeah, there are fewer steps than completing the square, but this isn't a walk in the park either, because now we have to simplify this horrendous mess, right? What I do is I always, and this is what I recommend you do, is simplify what's inside the radical first before you copy and go down. So let's see, this would be quantity minus 2 squared. That would be 4, and then minus, and let's see, I want to multiply the 4 and the 5 together to get the 20, and then the 3 makes it 60. This is negative 56. Minus sign in a square root, what the actual heck? I know what's going to happen. This is going to become square root of 56i. We have a complex number on our hands, don't we? It happens quite often in these. All right, so let's go back now and rework the whole problem, or just where we're at in the simplifying. This goes together to make a positive. So it's 2 plus or minus. Now we said the inside of this turned into square root of 56i. The I does not live in the pig house. The I sits outside. And then this is all over 6. Okay, that's looking really good. We're most of the way there. However, we want to simplify here if we can. 56 is not a prime number, so we might be able to break a pair of pigs out of this and get him to jump. And then I see, oh, well, if it's an even number, if we can break an even number out, we could factor a 2 out of all of these and simplify things a bit. All right, so let's see what we can do. 56, my brain goes to 8 and 7, and then this is three twos, right? So what I'm going to do is I'm going to take a pair of these 2 pigs and I'm going to jump them all the way out and put them on the outside. 2 pigs in the house is 1 pig out of the house, and then that will leave us with another 2 and a 14 left inside. So this will become x equals 2 plus or minus 2. That's the pair of pigs we jumped out. Square root of 14 is what's left inside. The I floats on the outside. Over 6. All right, then I'm going to factor a 2 out of this numerator. So it'll be, I'm factoring out the 2, so it'll be 1 plus or minus 1 times the square root of 14i over 6. I can cancel, now because these 2's were being added. I cannot cancel if I'm adding. I can only cancel if I'm multiplying. So I factored out that 2. Now I'm multiplying it, and now I'm allowed to cancel it against the 6. And that's a 3. So my final answer, I'm going to have to go to the top of the other page, aren't I, is x equals 1 plus or minus, I don't need to write this one, 1 plus or minus square root of 14i over 3, and I'm going to show you how we like to write that. X equals 1 plus or minus square root of 14i, and then before we had it all over 3, right? But here's the thing, we want to split this into 2 separate fractions because this is a complex number, right? Imaginary. And when we write complex numbers, we always want to protect this format where the imaginary piece is completely distinct from the real number. So that's why we write it like this. We want this to be our real number piece and this to be our imaginary piece, and we want a complete separation between the 2. So we just knock them apart and give them separate denominators, and guess what? That's the right answer. Is that easier than completing the square? Most people think so. It's not a walk in the park, like I said. It's still rather rough, but it gets the job done with a little bit less pain and agony. Fewer steps, right? Get it in order, identify A, B, and C, plug them in, and then simplify. Okay, let's do one more and then we're done. 71.2. I hope you feel really, really smart today. You've joined an exclusive club of people who know how to use the quadratic formula. It is at the very heart of what high school algebra is all about. So you have really joined the inner circle at this point, and I'm very impressed with you. All right, I'm going to do this the slow way. John tells us to solve this by using the quadratic formula. Okay, well, it's hard not to just get excited and go, okay, A equals B equals C equals. But we realize John's dirty dogging us here because he put these on the opposite side of the equation. It's not going to work until we get everything shoved over. So we have to go with that standard form, x squared. This will, as it changes sides, it will change signs. So it'll become minus 3x. And then same for this one, minus 28 equals 0. No kicking to the curb or anything like that. We're just bringing everything over and getting it organized. That's why we always took that step in completing the square also, even though sometimes we'd pull a number over and then send it right back. We wanted to train ourselves to always, always get standard form organized before we go forward. So there's our standard form. Thank you. When you're doing your homework, you don't have to copy it the wrong way. You can just fix it as you copy it out of the book. All right, A equals, B equals, C equals. Remember, the sign matters. So A is 1. Doesn't look like it, but there's an invisible 1 there. Minus 3, minus 28. Ugh, that seems unruly, doesn't it? We'll see what happens. Okay. So now we're ready to write the formula. And then we write it again with buckets. I know this seems like a lot of tedious copying. I'm telling you, if you want to get it right the first time, do it this way. If you want to have to go back and try to find your mistake and fix things and waste time on that, that's fine. I'd much rather get it right the first time. And that's what I'm teaching you how to do. Okay, B. I'm going to go, no, this time I'm going to do my A's, then my B's, then my C's. I'll use the other approach. A goes here and here. B goes here and here. And I'm just referring to this, right? This is like the map of how we fill it out. And then C only goes down here, minus 28. Okay, looks good. Now we have a bunch of simplifying to do. I always simplify the radical first. Minus 3 quantity squared will be 9. These two minuses go together to give me a plus. 4 times 28. Well, let's see. 4 times 25 is 100, right? Because that's 4 quarters. 4 times 25 is 100. That gives me 3 more. 3 times 4 is 12, so that is 112. 9 plus 112 equals 121. No negatives here, no imaginary numbers this time. Just square root of 121. And I don't know if your brain is doing this, but my brain is sending off some signals going, 121 is a perfect square. The square, let's write it down. I'll show you. Okay, we'll clean up as we go. This becomes a positive, plus or minus the square root of 121 over 2. Now, my brain is saying, hello, the square root of 121 equals 11. It's a perfect square. So I can rewrite this as x equals 3 plus or minus 11 over 2. This is like actual numbers, right? We can get for this 3 plus 11 divided by 2 and 3 minus 11 divided by 2, right? We can split it into separate answers. 3 plus 11 is 14, divided by 2 is 7. 3 minus 11 is minus 8, divided by 2 is minus 4. So the answers for this problem we can say are x equals 7 and minus 4. That's the answer. And we go, well, now wait a minute. Those are super easy answers. Is this problem simple enough that we could have solved it by inspection? When the answers are integers, when the solutions are integers, the answer to that question is usually yes. So let's take another look at this. X squared minus 3x minus 28 equals 0. And let's see, could we solve it by inspection? Well, it would be like this, right? We'd be looking for two numbers that multiply to minus 28 and add 2 minus 3. I know if this is minus, I know that the two factors are going to have to be positive and negative, so I can look for the difference between them to be equal to this, and my brain quickly takes me to 7 and 4. I know the numbers, I have to think about the signs. I want my answer when I add them to be negative, so that tells me the bigger number should be negative. Negative 7 and plus 4. X minus 7, x plus 4 equals 0. And now I know I can quickly do my zero factor theorem. Either that equals 0 or this tells me x equals 7 and this tells me x equals minus 4. Okay, this is doing it by inspection. It gives us the very same answer. So what is the point of all of this? The point of all of this is that the quadratic formula always works. You don't have to worry about, you don't have to worry about whether you could solve it by inspection. Completing the square and the quadratic formula work every time, okay? By inspection only works for problems with relatively simple roots, like integers, right? Like we just found, the 7 and the 4. But you don't have to worry about it, right? You don't have to worry about the man-eating dragon and is this the right method for solving this quadratic. It will always work. And we just proved it with this problem. We worked this problem as if its answers might be crazy, and when we got done, we saw, oh, actually it was a very simple problem that we could have done by inspection quite quickly, but it's okay. Man-eating dragon always works. In that respect, he is our friend. All right, that is the end of lesson 71 for the practice problem. John wants you to do what I just did back here. He wants you to start with standard form, and he wants you to use the steps for completing the square and go all the way through and get, there, it was up here that we finally got the answer, right? I had to turn the page, and get the actual quadratic formula. That's practice problem A. Okay, make sure you can do that. Right here, begin with ax squared plus bx plus c equals 0 and derive the quadratic formula. Use the quadratic formula to solve. There's one like we've just been doing, all right? So John wants you to be able to do the theoretical part too, where you take the letters and rearrange them. I just explained it all to you. You can rewatch this video. You can look at your notes. It feels a little challenging to work in the abstract like that, but you got this. All right, that is the end of lesson 71. Yay. Goodbye.